Welcome! Today we're going to update the status of solar cycle 25 for 2023. It has been an exciting year with solar activity at high levels. The sunspot number surpassed that of the peak of solar cycle 24 and is continuing to rise. We've had some spectacular events, including the biggest flare for 6 years that amazingly occurred just a few minutes before the end of the year. Let's summarize some of the high points of the year. 3 months ago, the smooth sunspot number for solar cycle 25 finally passed the peak of solar cycle 24, something that many have been saying could not happen if we were going into a grand solar minimum. The two biggest flares of the cycle so far happened in December. Other activity indicators are also on the increase, for example the number of coronal mass ejections. That in turn has caused an increase in geomagnetic storms and space weather events experienced here on Earth. Several times this year the Sun has produced a large number of big sunspot groups, but 2023 started off spectacularly with large spots in both hemispheres. This is a 1-week movie of that time. Note the size of the spots with respect to Earth, see the inset at the top right. Also, how they appear and disappear, move and collide. This is the source of flaring activity. First, let's compare the sunspots in December with the equivalent longitudes in November. The orange curve is December, the blue, November. So when the orange curve is above the blue, there was significant sunspot growth in that area and at that time. But when the blue exceeds the orange, there was sunspot decay. Overall, December had about 9% more sunspots than November. The official sunspot record is kept by the Solar Influences Data Center in Belgium. This is their plot covering the last 13 years. Solar cycle 24 is the peak on the left, and solar cycle 25 is the peak on the right. Note that solar cycle 24 has two major peaks, one in 2012 and a slightly larger one in 2014. That was solar maximum. There are three types of sunspot number plotted here. The yellow curve is the daily average sunspot number, and as you can see, it's highly variable, so it's difficult to track what's going on. To even out some of that variability, we take monthly averages of the daily data. That's the blue curve. Even that is highly changeable, so something called the smooth sunspot number is calculated by averaging over a 13-month period. This is the solid red curve. It is the lows and highs points in this quantity that we use to determine the dates of solar minimum and solar maximum. So it is an important number to track the progress of the solar cycle. These data form the basis of most solar cycle prediction models. In that jumble of different sorts of data, it is often difficult to see the trend in the smooth sunspot number. So I've plotted it separately here just for solar cycle 25 so far. Because this is a 13-month smoothing algorithm, the most recent point we have is in June of 2023. You can see that the curve is still rising, so we're not at solar maximum yet. However, the rate of rise has slowed recently, so the question is, how soon will the cycle peak? Solar cycles have a way of fooling us in that sometimes, actually quite often, they have multiple peaks, separated by several years. So even if this peak starts to come down, it may start to rise again, so it could be several more years before we can identify the final maximum of solar cycle 25. At the moment, solar cycle 25 has already exceeded the peak of solar cycle 24 by about 8%. That is significant. About 5 years ago, NASA and NOAA put together a panel of experts on the solar cycle, and they made a prediction based on the sunspot number and F10.7 centimeter radio flux, which is another indicator of solar activity. The plots are seen below here. They predicted that solar cycle 25 would be about the same, perhaps marginally higher than solar cycle 24. This is their early prediction. They predicted a maximum in the smooth sunspot number of about 120, with the peak occurring in 2025. The solar cycle 24 peak at 116 in 2014. But as you can see, solar cycle 25 has significantly outperformed their prediction. so they recently revised their model upwards. This is the new NASA NOAA Solar Cycle 25 prediction. They are increased by about 30% over the original models. For example, the peak in the smooth sunspot number is now 155 plus or minus 18. There have been much higher predictions made as well, some exceeding 200. The Solar Influences Data Center uses 3 different models to predict the cycle's progression over the coming year. The first is called the Standard Curves model, on the left here, which basically averages out the shapes of past cycles and then fits it to the rise of the current cycle. That is predicting a peak of about 150 in May of 2024. The second is what's called the combined method, which does exactly what it says. It combines the results from several different techniques. That is predicting a lower smooth sunspot number of about 130 by the end of 2024. But it does not preclude going back up again. In fact, none of these models do. Remember, they are merely projecting forward for the next 12 months, not beyond. The third method is called the McNish-Lincoln method. It seems to be predicting a flattening of our sunspot cycle over the next 12 months, with a peak of about 135. Any of these models could be right, or more likely, none of them. I have been tracking the number of major sunspot regions on the Sun during this cycle. This is a plot of that quantity over the first 4 years of Solar Cycle 25. The criteria for a major sunspot region is that NOAA has numbered it, which they do not do for all sunspot groups. Solar Cycle 25 is shown in orange and Solar Cycle 24 in blue. As you can see, once again, Solar Cycle 25 is outperforming Solar Cycle 24, and by a margin of about 24%. If this were translated into a value for the solar maximum, it would give a peak on the smooth sunspot number of about 143. The record flaring rate in 2023 was 25 flares in just one day. That was 3 M flares and 22 C flares. This is a movie of that time, for the 5th of December. See if you can keep up with the flares from the various regions. These images are taken at 6 million degrees, so even minor flashes here are significant flares. We had a bumper crop of flares in December. There was a grand total of 279 C flares, the second highest flare rate so far this cycle. Comparing the Solar Cycle 25 flaring rate, the orange curve, with the equivalent stage of Solar Cycle 24, the blue curve, Solar Cycle 25 has produced 97% more flares during the first 4 years of the cycle than Solar Cycle 24 did. Note at this stage, Solar Cycle 24's rate was beginning to level off, while Solar Cycle 25 is still rising at a rapid rate. We see a similar story in the number of M flares. M flares are flares that have an X-ray flux 10 times greater than C flares. In December we had 23 M flares, so Solar Cycle 25 is outpacing Solar Cycle 24 in M flares by a factor of over 2 to 1. If this rate were reflected in the amplitude of Solar Cycle 25, it would predict a maximum of about 250. As with the C flares, after 4 years, Solar Cycle 24 was leveling off for a while. Remember, there was a second peak in Solar Cycle 24. However, Solar Cycle 25 is still continuing to rise at a greater rate. As I mentioned earlier, we've just had the largest flare of Solar Cycle 25 so far. It happened just minutes before the end of the year and was an X 4.8 flare. Let's take a look at it as seen by the AI instrument on the Solar Dynamics Observatory. This image was taken at 10 million degrees, a high enough temperature to instantly vaporize anything here on Earth. Although the statistics are poor for X flares, it shows a similar trend to the other two categories, namely Solar Cycle 25 is outperforming Solar Cycle 24 by an increasing margin. We have seen 22 X flares so far this cycle compared to just 15 for the same period during Solar Cycle 24. X flares are more likely during the peak and decay of Solar Cycle 25. Coronal mass ejections are the expulsion of large volumes of plasma from the sun's surface. They can be caused by flares or by filament eruptions. Here are some examples of some of them. Many of these coronal mass ejections are much larger than the sun itself, seen here in the middle of the occulting disk, so dwarf the Earth. Any on the western side of the sun, that's the right hand side, are primed to come towards the Earth and can cause geomagnetic storms if they hit us. As might be expected, the number of coronal mass ejections during solar cycle 25 is outpacing that of solar cycle 24, but only by a margin of 31%. Why the difference between the flare rates and CMEs? Well, not all CMEs come from flares. Many result from the eruptions of filaments and prominence that have little or no flare activity associated with the coronal mass ejection. It is an oddity that the polar regions have a different magnetic polarity than the rest of the hemisphere. This is a map of the sun's magnetic field over the last 50 years. Note that solar cycle 25, far right, started with a positive northern polar region, that's yellow, and which is slowly being replaced by a negative field, blue. In the southern hemisphere, the reverse is happening. Initially, a negative polar field is being replaced by a positive field. These replacement fields originate from sunspot regions, and it's all part of the long-term magnetic cycle of the sun. Filaments form at the magnetically neutral boundary between the opposed polar and hemispheric fields. They can be seen as dark rings surrounding the polar areas, so they are called polar crown filaments. I have highlighted them here in red. They're getting hard to see as the corona expands during the increase to solar maximum and hides it from our view. They've shrunk considerably in the last year. Typically, polar fields disappear along with polar crown filaments near solar maximum. As we can see the polar crown filaments, it means that we are still not quite yet at solar maximum. But as they are shrinking and getting less prominent, it means that the solar max is not far away, probably of the order of a year. Another important parameter to track on the sun is the total solar radiance. That's the amount of energy the Earth receives from the sun. The sun provides the Earth with 99.99% of the energy we receive. It changes with the time and year and as the Earth orbit brings us closer or takes us further away from our mother star. It also changes with solar cycle and activity levels. This is a plot of the total solar radiance over the last 20 years. The orange peak in the middle is solar cycle 24, the red one on the right is solar cycle 25. Plainly, in terms of total solar radiance, solar cycle 25 is already more active than solar cycle 24. An interesting side issue here is why is total solar radiance during solar maximum, at the time when there are lots of dark spots on the sun which should drop the amount of energy coming from the sun, but it does not. Why? We discovered the bright areas around sunspots, called faculae, actually produce more energy than the sunspot deficit, so we get more energy at solar maximum than at solar minimum. This is a combination image where you can see both the large dark sunspots scattered across the disk and around each one of them a bright area. That is what we call faculae. What the sun loses in brightness due to the dark spots, it more than makes up for with the additional emission from faculae. So what conclusions can we draw from all of this? All activity indicators are up for solar cycle 25 compared with solar cycle 24. That is sunspots, f10.7 centimeter radio, flares, C, M and X class, coronal mass ejections and total solar radiance. All activity indicators are exceeding solar cycle 24 peak values, so solar cycle 25 is going to be larger than solar cycle 24. That effectively ends all discussion of a possible grand solar minimum this cycle. Solar maximum may only be a year away, so will be in 2024, possibly in 2025, at a level between 180 plus or minus 50. I would like to take this opportunity to wish you all a happy new year. Thank you for watching, and until next time, stay safe and goodbye.